Here we are at the bench again, ready for more inmove building. Last time we looked at the left forearm, and this time we'll be taking a look at the rotational wrist. The original inmove wrist was one single piece and didn't have a servo to provide rotation. The rotational wrist has been available for some time now and seems like an easy upgrade which will give greater flexibility to the hand. So I thought I'd mix up the format a little bit this time and take a look at all the parts before we start. I like to use the names of the parts so you know which bits I'm talking about, but I often get them wrong. So this time I thought I'd print out each part along with its name so we can just quickly run through them. These parts have a version number on the end, a V number, which I won't be mentioning here. My recommendation is just make sure you've got the latest version of the parts. If you're getting your parts from the inmove FR site, avoid the zip files. I made the mistake of downloading those and they can contain outdated parts. If you get your parts from the STL parts library, they're always up to date. So first we have left rotor wrist 1. Left rotor wrist 2, left rotor wrist 3, left cable holder wrist, and finally wrist gears. So starting with left rotor wrist 1, we saw this part last time. We already have it super glued onto the end of the forearm. Just needs painting. So not really much more to do with that. The servo will screw in here, attached to the end, so that'll be one of the first things that we're doing. Left rotor wrist 2, we briefly saw that last time as well when I was installing the 3mm nuts. I've given it a quick coat of primer. My intention is to paint this part black. I did miss one of the nuts last time. We installed 2. There is actually a third one I need to fit in here. Brings us on to left rotor wrist 3. I have actually had this part printed for some time now. I forgot about it, tucked away in my containers. Not much to say about that really. I've sanded it down, just needs a coat of paint. Probably paint this part white, not sure yet. So then we have left cable holder wrist. The tutorial states that this glues onto the top of the servo. It does seem to have 2 fixing holes though, so I presume the part's probably been updated since the tutorial was written. My understanding of this part is it's just there mainly to keep the cables tidy. It looks like one cable goes through each of these holes. These are the cables that run down to the fingers, just to stop them getting twisted and tangled. Again, I've sanded it, not sure if I'll paint it or not. So that's that. Then lastly we have wrist gears. I printed out a new set of these. I did originally print them with my original printer and I thought I may as well print a new set off the new printer. Hopefully they're slightly better quality. This is exactly how they've come off the printer with the brim still attached. There are 3 gears, but we only use 2. We obviously use the large gear, which has holes again to run the cables through. And the tutorial states that we are to select the most suitable smaller gear. So I have no idea what that means. Possibly different servos fit different gears. I have no idea, so I guess we'll find out when we come to it. I'll just very quickly show you the servo I'm using. This is the MG996R. Not quite sure who the manufacturer is of this. I actually managed to pick up these on eBay for £4.39 each, so I don't think you'll be getting a much cheaper price for a servo. I'm thinking about, because of the cost, I'm thinking about using these to drive the fingers as well, because when we did the forearm in the last video I didn't have any servos. I picked up 4 of these, so I've actually got 3 spare ones, so I may install 3 of them into the forearm and see how they get on driving the fingers. This is, as the name states, MG. This is a metal gear servo, so it should be a little bit stronger than the plastic gear servos. It says on there Digi high torque, I believe, so I think it's a slightly higher torque servo than normal, and it's a digital servo rather than analog servo. Comes with a fairly short lead. That shouldn't give us any problems though. You get 4 different servo horns to choose from. You just select the most suitable one for your application. We're actually going to have to cut these down and attach them to the small gear, I believe. So I'll probably use this one because it will mean the least amount of cutting. These are the mountings. I'm not sure if I'll use these. These are rubber bushers. I believe they're for anti-vibration, to stop the vibration of the servo. So I've started to put the servo in. You push the cable down first, and the cable is on this side of the servo. There is a groove down there that gives you a little bit of room to get the cable in, although I say a little bit of room, it is really tight. I pushed the servo down as far as it can go, and it seemed to stop at this point. Looking inside, there is this plastic bar running across here, and sorry you can't see very well, but that servo is actually sitting on it, it's hitting it, so it won't go down any further than that. I don't know if you can tell here, but there is a gap here under the servo, reasonable sized gap. I found that if I fit the rubber grommet, there's still a gap, and then if I fit the metal sleeve that runs through, the metal sleeve is actually touching on there, so everything is actually perfect. And then I just installed the screw. You get very little thread left on the screw after you've run through that length, so don't over tighten it. It doesn't seem. Okay, I've installed all 4 screws now. I did briefly fit the next part on the top. It is very tight. You kind of just have to have faith that it will fit, and just gently squeeze the tabs and then give it a good push down. I'm not going to put it back on again just now because it's quite tricky to take back off again, and it feels quite fragile, and I think if you're not careful you could snap these plastic lugs off. So if you do fit it on and you want to get it back off again, what I did is I just prized it off with a flat-headed screwdriver and just lifted it back out. But it is very tight. I believe I probably need to go back and check the tutorial. I believe the next stage is to put this gear through this hole, so that will poke up through that hole, and then this part should slip on the top. There is a hole, really difficult to see on the camera, there is a hole in the side there, and that should line up with the hole in here, and then a screw through there should hold that in place. So this has to slip up through that large hole, but it doesn't fit. It's too big to fit through there, so I'm going to have to file that down. Also, it should slip inside this hole as well, and again it doesn't, it's too tight. So I guess we're going to have to do a bit of filing. Okay, that's better. That now slips in there, so you can now see how that's going to work. That's nice and loose in there now, that rotates easily. It's just how we want it. And then that piece will fit on the top. I'll screw that on now. So that's there with the bracket fitted on. It's a little loose. I could put a spacer under there, I guess, to tighten it up. But that'll do for now. Okay, so what I did to select the gear was to measure from the joint in the forearm to the top of the servo horn, and that came to 20 millimeters. I then measured inside this piece from the bottom of that piece to the joint, and that measured 25 millimeters. So there's actually only 5 millimeters to play in here. Looking at the two gears we have to select from, you can see that one is shorter than the other one, and measuring the short one, it measured 5 millimeters. So it seems this is the correct one to use. I guess this must be for a different type of servo, or maybe for attaching directly onto the servo instead of using the servo horn. I'm not quite sure, but this seems to be the only one that's going to fit in my scenario. You can actually see I've taken this apart again. So this smaller gear has got a little raised part in the centre, and that looks to me like it fits into the small hole in here. I'll do it this way around. I know it doesn't go this way around, but just be easier to show you. So that fits into the smaller hole, and then it should mesh with this gear in the larger hole. Now they are meshing, but they're pretty tight, and I don't know if you can see that, but the smaller gear, sorry my hands are in the way here, so you can actually see the smaller gear is just sort of kicking upwards, and that's just because these gears are too tight. I've filed them, I've filed every single tooth down, and they just seem very tight. It might be loose enough now after that filing, but I'm not sure. So we somehow have to get these gears on the inside of this part. The larger one, straightforward, that can go in there, and we saw before I had the bracket attached on, that will hold the gear in place. The smaller one, okay, the smaller gear has to fit onto the servo, so we put the horn on. You can see I've used the smaller horn, and I've chopped the ends off, and then I believe we have to super glue this gear on the top. I say super glue because there's no room at all to get any screws in that small piece. There are a couple of holes still in it, but they're too close to the edge. There just isn't enough room to screw that on. And normally you would fit the servo horn, and then there would be a little screw that would screw the servo horn into place, but I believe that would leave the head of the screw just proud, sticking upwards, and this gear is flat on the bottom, so I don't think we can fit the screw. So I think we just need to glue these two parts together, the servo horn to the small gear, and then it will just sit on there. Shouldn't go anywhere because the top piece here will be holding it down, so it can't really move anywhere. So I think that's going to work. The other thing I've discovered, I've looked at a couple of bits. This sort of cable guide piece, that seems to fit there. If I could try and show you in here, it'd be pretty tricky to see this. Yeah, that seems to sit pretty much as I've got it now. The two holes in the top seem to line up with the two screw holes. So I think the answer there is to remove these two screws and fit longer screws that go all the way through. I might struggle to find a screw that's long enough and thin enough to fit down that hole. Maybe I won't fit this part to start off with, unless I can find some longer screws. I'm kind of stuck with that. The other thing I discovered, I must have fitted this part before I put the servo screws in, because it did fit quite snugly here, but with the screws in, you can see I've taken the screws out, this part won't fit on. The screw heads stick up too much, there's no recess in here for the screws. I've removed the screws and tried fitting it again and it's still too tight. I'm even going to have to remove the rubber mounts and the metal sleeves. They're all going to have to come out. There's no way this piece is going to fit on top with those in there. Okay, I've gone right back to the beginning and removed the servo. I've drilled these two holes here. I've drilled them out to 2.5mm. I'm intending to fit this long 3mm screw through the cable holder, through the servo and into this bracket. Next, I've drilled out these two holes to 3.5mm so they can be clearance holes for our 3mm screw. Fits in there nice and loose. So I've glued the smaller gear onto this cut down servo horn. So that will then just sit on there. Like I said before, we can't screw that in now. We've got the gear glued on. I guess we don't need to. So we're nearly there. We just need to plug the servo into the Arduino and get it centered at its 0 position, or its 90 position, I'm not sure. And then work out where this is supposed to be positioned, and then drop it on. So I've just loaded this standard sketch from Arduino onto my Arduino Mega board. As you can see, it just loops through from position 0 to 180 and then from 180 back to 0 again, and just keeps repeating that. And you can probably hear it in the background. See, this small gear is rotating. Looks like it's about 180 degrees. Thinking about this, if this small gear is rotating at 180 degrees and we've got the larger gear in there, I'm guessing this wrist won't actually have a full 180 degrees of rotation on it, because we'll lose a little bit in the gearing. So I'm not quite sure whether that's 2 to 1 and we'll get about 90 degrees, I don't know. Okay, apologies for doing this off camera. I had a few problems with this gear. This gear is just super glued to the servo horn, as we saw earlier. What kept happening was the gear just kept shearing off from the servo horn. The glue just weren't holding it. So I made a couple of changes. I've actually run a screw through here, an M3 countersunk screw, right through the gear and into the servo. It's just an M3 screw. It seemed to fit the thread on the servo, but you do need one a fairly precise length. And again, apologies, I can't remember what length that was. I don't really want to take it apart again. I put some thread locker on the end of the screw as well, where it screws into the servo, because what was happening was, as the servo rotates in one direction it's fine, but when it rotates in the other direction it actually undoes the screw. So the idea being, I put some thread locker in the screw to try and hold it in position. And you can see I've made a bit of a mess here. I've applied some grease around this. The other modification I made was in here. Again, apologies for doing it off camera, I don't really want to take it apart, but I 3D printed a small spacer to go in here. It's just basically a plastic washer, about 2mm thick. That just takes off any slack, so this is now nice and tight. It's not too tight, it still rotates okay, but there's no wobble in it sideways. It's nice and tight. And then just applied some grease in there as well. So there it is, fit together. Got the same sketch running on the Arduino. So we've just got it rotating backwards and forwards between 0 and 180 degrees. As you can see, as I mentioned before about the gearing on this, we don't get 180 degrees rotation in the wrist. Probably getting about 90 degrees there. And here we have it with the hand semi-attached. I couldn't quite get this bolt through here. I've got a couple of problems to sort out. There's a bolt running up here and the head is just slightly proud, sticking out at the bottom. You can just see it in there. And that's preventing me from getting the bolt to run through the side. So what I'll have to do is just take this bolt out, just shave a little bit off the end of it and then put it back in, and the head should be fully recessed, and then I'll be able to get the bolt through. We'll need to take this apart again to actually run the cables through for the fingers. They're just all round the back at the moment. They need to be run through here. They'll go through these holes in here, through the wrist, down into the forearm. So in the next video I hope I'll get the servo bed fitted, get a couple of the servos in and run the cables through for the fingers. We should start getting the fingers moving. Okay, thanks for watching and I'll see you next time.